Hi, today we'll be solving engineering mechanics gate 2 marks questions from question number 11 to question number 20. So let's start. So this is the first question. A rigid rod AB of length L is equal to 2 meter is undergoing a translation as well as rotation motion. Okay, translation as well as rotation in the XY plane. Okay, so this is a 2D motion as shown in the figure. The point A has a velocity of I cap plus 2j cap. So this point A has a velocity of I cap plus 2j cap. The end B is constrained to move only along the x direction. So there is a wall you can see. So the end B can only move in x direction. There is no other velocity possible. The magnitude of velocity V2 at the end B is. Okay. So there is a very fantastic question. Let us see the concept that is required first. First, you have to understand that what concept this question wants to test. So, if there is a rod AB, if there is a rigid rod AB, rigid rod, please mark my words, rigid rod AB, the velocity of the points A and B, the velocity of the points A and B in the direction of the rod, along the rod, has to be equal. Has to be equal. VA should be is equal to VB. And why so? Because the rod is rigid, so the rod cannot elongate or rod cannot contract, right? So if the velocities are different, so the rod will either elongate if VB is greater than VA, or the rod will contract if VB is smaller than VA. So that is not possible. So VA has to be equal to VB. So this is the concept that will be used in this question. Okay. So I can solve this question by two methods. One method, I'll just say it to you how to solve. I'll solve it by the second method, which is a more interesting method because that will give you more insight into mechanics. So what is the first method? The first method is that you can find out this angle alpha. How to find out this angle alpha? It is easy. Can we calculate this angle, let me say beta? Can you calculate this angle beta? Yes, definitely. Tan beta is equal to perpendicular by base. Now see the velocity v1 is equal to I cap plus 2j cap. I cap plus 2j cap. So perpendicular is definitely the j cap component, 2 divided by the I cap component. Base is the I cap component, 2 by 1. So from here you'll get the value of beta. ये तो solve हो ही गया ऐसे तो. Tan inverse 2, it is equal to 63.435. 63.435. So since this is a numerical answer type question, I will prefer to take 3 decimals after sorry, three significant digits after decimal, three places after decimals. Okay, so can I find alpha now? What is the value of alpha? Alpha is equal to beta minus 45. So this will come out to be minus 45. If I do, this is coming out to be 18.435. 18.435 degree. Right. Now, what is the magnitude of V1? What is the magnitude of V1? Magnitude of V1, vector V1 is equal to root over 1 square plus 2 square. Are vector V1 is given, na? So if you take out the magnitude of V1, it will be root over 1 square plus 2 square. Right? So this is coming out to be root over 5. So magnitude of V1 cos of alpha should be is equal to magnitude of V1 cos of alpha. Magnitude of V1 cos of alpha, that is component of V1 along the vector AB. Component of V1 along the vector AB. Component of V1 along the vector VB should be equal to component of V2 along the vector AB. Component of V2 along the vector AB. So what is this angle? This angle is 45 degree. This is given. So you can see, I hope this need not be explained. Now this should be is equal to V2 cos of 45. Right? Substitute the values of alpha, substitute the value of V1, mod of V1, magnitude of V1, and substitute the value of cos 45. You'll get the answer. You'll get the answer. V1, sorry, not V1. We need to find V2. V2 is equal to 3 meter per second. So this is the answer. Solve हो ही गया वैसे first method से. I thought I will not solve it. Okay, ठीक है. So this is the first method. I hope it is clear to everybody. Let us see the second method, which is a more interesting method. Let us see the second method, which is a more interesting method. I'll get more insights into engineering mechanics, especially into vectors. Okay. Can I say the vector AB? The vector AB, can I say this is equal to L cos 45 degree I cap plus L sin 45 degree J cap? Yes or no? Vector AB, AB का length given है ना? The length of AB is given, so I can say vector AB is equal to L cos 45 I cap plus L sin 45 J cap, right? Substitute the values, you'll get L is root 2, cos 45 is 1 by root 2, so this becomes I cap plus J cap. So this is the vector AB. This is the vector AB. Now if I want to find out unit vector along AB, what is the unit vector along AB? That is AB cap will be is equal to vector AB divided by magnitude of AB, right? So vector AB is I cap plus J cap. What will be magnitude of AB? Magnitude of AB will be root over 1 square plus 1 square. So this will become I cap plus J cap divided by root over 1 square plus 1 square, right? So unit vector AB is equal to I cap by root 2 plus J cap by. Okay, you'll get to know why I am finding out this. Now, if you want to find out component of V1 along vector AB, so if you want to find out component of V1 along vector AB, how can I write it? Component of velocity V1 along AB. This can be given by, this is the most important point, component of V1 along vector AB can be given by dot product of V1 and a unit vector along AB. So this is equal to V1 dot unit vector AB. So what is V1? V1 is already I know I cap plus 2j cap. Dot product of unit vector of AB is I cap by root 2 plus j cap by root 2, right? So if you do the dot product, so this will become is equal to 1 by root 2 plus, I hope you know dot product, 1 by root 2 plus 2 by root 1 by root 2 plus 2 by root 2. And what it should be equal to? Can I say it should be equal to V2 cos 45? Again, same concept, right? The component. So what we have found out is the component of V1 along AB. So this is the component of V1 along AB. So this should be equal to V2 cos 45 because the component of V1 and V2 along the dot should be equal, right? So I can say this is equal to 1 by root 2 plus 2 by root 2 should be is equal to V2 of cos 45. So you know the value of cos 45, I can directly write it down. Cos 45 is how much? V2 1 by root 2. So root 2 will cancel out. So V2 will come out to be 3 meter per second. So again, this is a very fantastic method, and I told you by this method also because uh, the length is given as you can see, right? And this is a more interesting method. You'll get some insights into vectors also. Okay, let us move on to the next question. A circular disc of radius 100 mm and kg 1 and 1 kg initially at rest at position A rolls without slipping down a curved path as shown in the figure. The speed v of the disc when it reaches point B is. Okay, so this is again a good question from the chapter of rolling. Right? So basically we'll use conservation of energy, mechanical energy here, right? So decrease in potential energy, I can say decrease in potential energy. So whatever potential energy has decreased, this will result in increase in kinetic energy. So how much potential energy has decreased? If you see the center of mass has come down by 30 meters. So mgh, where m is the mass, that is equal to 1 kg, g is given as 10 meter per second square, and h is 30 meters. This should be is equal to change in kinetic energy. Now, this is important. So if you consider the motion of the if you consider the rolling about instantaneous center, so this is the instantaneous center, this becomes the IC or instantaneous center of rotation, right? So anyways, how can I write the kinetic energy in rolling? I can write the kinetic energy in rolling as half I omega square, half I omega square, right? So instantaneous kinetic energy, this is a disk, circular disk about the ICOR. Let me substitute the values. mg h is equal to half I will be 3 by 2 mr square, 3 by 2 mr square, the moment of inertia of the disk about the ICO. So this is something you should remember. Omega, I can definitely write it as V by R. I can definitely write it as V by R. So R is getting cancelled, as you can see. You can directly say V square, right? So let me substitute the other values also. Some things will get cancelled out. Mass will get cancelled out. Radius R will get cancelled out because square hai dono taraf. So from this, I'll get the value of V square is equal to the 4 by 3 GH. I hope I'm right. To the 4 GH by 3 V square. So what is the value of V? Let me substitute the values. G is already given as 10 and H is given as 30, 300. Okay, this is 400. So it is coming out to be 20 meter per second. 20 meter per second. Again, a very simple question, but very conceptual question, very fantastic question. Very conceptual. I hope you got it. Let us move on to the next question. Let us see question number 13. An inextensible massless string goes over a frictionless pulley. Two weights, 100 Newton and 200 Newton, are attached to the two ends of the string. The weights are released from rest and starts moving due to gravity. The tension in the string is okay. So it starts from rest and it starts moving due to gravity. Definitely, I can say the higher mass will go down, right? The higher weight will go down and the lower weight will go up. Okay, there is no doubt to that. Okay. So let me say the acceleration of the 200 Newton mass is A downwards. So the acceleration of the 100 Newton mass will be A upwards because this is one string. Let me say the tension in the string is T. Let me say the tension in the string is T, right? So how to proceed with these questions? Proceed very, very simple. You have to draw the FBD of the masses. The first step is to draw the FBD of the masses. So let us draw the FBD of 100 Newton. 100 Newton force. So there is a tension force in the upward direction. There is a mg force that is equal to 100 Newton, right? Mg that is equal to 100 Newton in downward direction. And since it is accelerating upwards, I'll apply inertia force in the downward direction. Since it is accelerating in the upward direction, I'll apply a inertia force in the downward direction, which is equal to mass into acceleration, ma. So mass into ma, what will be the mass? Can I say mass is 100 by g into acceleration a, right? So what will be the equation like now? The equation is like T is equal to 100 plus 100 by g into e. This equation number 1. Okay, let us see. We will proceed to the second equation. FBD of 200 Newton force, Newton mass. So if you find out the FBD of 200 Newton mass, so there is a tension T in the upward direction. 200 Newton in the downward direction, the weight. And since the body is accelerating downwards, since the body 200 Newton mass is accelerating downwards, so I'll apply inertia force M into A in the upward direction. So what is the mass M? 200 by G into acceleration A in the upward direction. So I can rewrite this equation as T plus 200 by G into A is equal to 200, right? I can actually take 200 by G on the left hand side, so I can write down equation 2 as T is equal to 200 minus 200 by G into A. So this becomes the equation number 2. So we have to find out T. We'll directly try to find out T. What I can do, I'll multiply equation 1 with 2. I'll multiply entire equation 1 with 2, right? So it becomes 2T is equal to 200 plus 200 by G into A. Then I'll subtract equation 2 from equation 1. If I subtract equation 2 from equation 1, oh sorry, I'll not subtract, I'll in fact add equation 2 and equation 1. So if I add equation 2 and equation 1, so how am I going to do it? What I'm saying is what I'm going to do is, I hope you are able to see this equation. I hope it is not covered by my this equation 1. Okay, so I'll multiply. What I'm going to do is 2 into 1 equation 1 plus equation 2, right? So the left hand side will become 3t is equal to 200 plus 200 is 400, and you can see the acceleration term will get cancelled. 200 by G into A minus 200 by G into A. So from here, I'll get the value of tension as, from here, I'll get the value of tension as 400 by 3, that is equal to 133.33 Newton. 133.33 Newton. So this is the answer. I hope it is clear. Okay, let us go through the question of 14. It's a very fantastic question, very conceptual question, right? Easy question, but very, very conceptual question, right? It will be very difficult to answer this question without having a very, very good knowledge of angular momentum. Okay, so a system of particles in motion has mass center G as shown in the figure. The particle I and M, particle I has mass Mi, and the position with respect to fixed point O, is given by the vector Ri. The position of the particle with respect to G is given by the vector rho I, right? Ri is with respect to fixed point and rho I is respect to point G. The time rate of change of angular momentum of the particle about G. So you need to find out the time rate of change of. So rate of change of angular momentum. Now, first of all, you'll have to understand what is angular momentum. So if I say angular momentum, it is represented by L. Angular momentum is generally given by, normally what we study, right? It is R cross P. So what is R here? R is the position vector. So if I am taking out angular momentum about point G, so this is RG, right? So this is position vector with respect to point G. Position vector with respect to point G. And what is this? This is linear momentum. What is this? This is basically linear momentum. P. This is not rho, this is P. P is linear momentum, which can also be written as mass into velocity. So this is the general formula, right? So here you can see the Rg is represented by rho I. Rg is represented by rho I. So if you want to take out, if I want to write down the rate of change, angular momentum, before finding out the rate of change, let us at least find out the angular momentum. Angular momentum of the ith particle about point G, is can be given by rho into I. So this becomes the position vector of the particle I with respect to the point about which you are finding out the angular momentum, cross Linear momentum is mass. Mass is scalar quantity, no problem about it. Now velocity. Now how to find out velocity? How to find out velocity? Velocity is derivative of the position vector. Now this position vector has to be about a fixed point, right? About a fixed point, that is O, right? This position vector, because whenever you are finding out the velocity, it always has to be from the origin. The position vector has to be from origin. So if I am finding out velocity about point G, if I take the position vector rho I, if I'm trying to find out velocity of point about point G, the problem is that that will be relative velocity. That is not the absolute velocity. And here I want the absolute velocity. So it has to be from the origin, that is from the fixed point O, right? So it will become Ri, right? So this is the position vector. I differentiate it once, it becomes the velocity. I differentiate it once, it becomes the velocity. So if I want to find out angular momentum about point Z, rate of change of angular momentum, not exactly angular momentum. So I'll write it down as rate of change of angular momentum. Rate of change of angular momentum. So basically, total about Z is equal to summation of all the particles. Summation is from I is equal to 0 to n, right? Cross m I and r I. Single dot was velocity. So if I'm finding rate, right? So this is actually dlz by dt. dlz by dt. This is the rate, right? This is not angular momentum. This is the rate. So I'll say this is equal to double dot. So if you search the answer, what is the answer? Answer is B. Answer is B. Okay. A mass of 2000 kg is currently being lowered at a velocity of 2 meter per second from the drum as shown in the figure. The mass moment of inertia of the drum is 150 kg per meter square. On applying a brake, the mass is brought to rest in a distance of 0.5 meter. The energy absorbed by the brake is okay in kilojoule. Okay, very fantastic question, very conceptual question. Now, the energy absorbed by the brake. What kind of energy is being absorbed by the brake? Can I say the kinetic energy? It is brought to rest. So if I try to find out the total kinetic energy of the system, entire system, that kinetic energy was actually absorbed by the brake, isn't it? So I can say the energy absorbed by the brake is nothing else but a kinetic energy, right? So I can find out the kinetic energy. Now there is a twist here. Okay, there is a very conceptual question. You simply find out the kinetic energy. It will not be the correct answer. I'll tell you why. I'll tell you why. What exactly is the thing? So let us try to find out the kinetic energy first. So what is the kinetic energy of the block at this instant? This instant. At this instant, kinetic energy of block. Kinetic energy of block. This is equal to half mv square. राइट काइनेटिक एनर्जी ऑफ द ब्लॉक इज हाफ mv स्क्वायर तो ये हाफ mv स्क्वायर क्या हो गया बेटा बोलिए सॉरी हाफ mv स्क्वायर इज इक्वल टू 2000 मास इज 2000 एंड वेलोसिटी क्या है व्हाट इज वेलोसिटी 2 मीटर पर सेकंड ओहो 2 मीटर पर सेकंड 2 स्क्वायर सो ये कितना हो गया 4 4 2 जा 8 1 2 कैंसिल हो गया तो 4 इज 4 किलो जूल आई कैन डायरेक्टली राइट 4 किलो जूल okay, let us try to find out what is the kinetic energy of the drum. The kinetic energy of drum is half I omega square. Kinetic energy of the drum is half I omega square. Yes or no? The value of I is given. Omega I can write it as V by R. Velocity V at this point. What is the velocity of this point? This point is V. String is inextensible. Na? The velocity with which the mass is coming down, the same will be the peripheral velocity of the drum. So if this velocity is v, what is omega? Can I say omega? If this is omega, sorry, और अच्छी तरह से बना देता हूँ. Let me say this is omega. So can I say v is equal to omega by r? ये r दिया हुआ है, diameter दिया हुआ है, तो r कितना हो जाएगा? R is 1 meter, right? So okay. Let me write it down. This is equal to half moment of inertia is 150 kg meter square given, right? Omega is v is 2 divided by r, it is 1 whole square. So this is coming out to be, if you calculate it, 4 it to 300 joule. 300 joule is 0.3 kilojoule. So my tendency will be to answer. See, this is a very nice question. So this is the total kinetic energy of the system. So what I will do, okay, I will say this is the total kinetic energy of the system, and then I'll say this has been absorbed by the brake. So this is 4 plus 0.3, that is 4.3. So the energy absorbed by the brake is 4.3. If you read the question properly, that is not correct. If you read the question properly, okay, the mass is brought to rest in a distance of 0.5 meter. The mass is brought to rest in a distance of 0.5 meter, right? So basically, the mass has traveled a distance of 0.5 meter when it has brought to rest, right? So when it is traveling a distance of 0.5 meters, so it is coming down, coming bound by distance of 0.5 meter. So if it is coming down by distance of 0.5 meter, so there will be decrease in potential energy, and by conservation of energy, I can say the decrease in potential energy is gain in kinetic energy of the system. So definitely, because of the block being lowered by 0.5 meter, there is some amount of increase in kinetic energy. There is some amount of increase in kinetic energy. So what is the total increase in kinetic energy? So delta PE, so decreasing potential energy is equal to gain in kinetic energy, is equal to gain in kinetic energy. So what is delta KE? What is delta KE now? Then delta PE is equal to mg h is equal to delta K, means increase in kinetic energy, that is equal to m is given as only mass. Now the drum is only rotating, the only mass is coming down, 2000 into g is 9.81 दिया हुआ है क्या, g का वैल्यू और कोई दूसरा 10 दिया हुआ है क्या, नहीं, ओके. So 9.81 into h is given as 0.5. 0.5. So what is this 2000 into 9.81 into 0.5? 2000 into 9.81 into 0.5. This is coming out to be 9810 joule. So divided by 1000 becomes 9.81 kilojoule. So the final total energy, okay, total energy is equal, this is equal to 9.81 kilojoule. 9.81 kilojoule. Sorry, so much of sound, background noise. I'm extremely sorry for that. So therefore, total energy absorbed by the block is equal to 9.81. This is the kinetic energy gain because of decrease in potential energy, plus initial kinetic energy of the block was 4 kilojoule, plus initial kinetic energy of the drum was 0.3. So the final answer will be plus 4 plus 0.3, that is equal to 14.11 kilojoule. 14.11 kilojoule. I hope it is clear to all of you. So let us move on to the next question. Okay, so a two-member truss PQR is supporting a load W. The axial force in the members PQ and QR are respectively the options are given. Okay, so if you try to analyze, we will have to proceed with method of joints. This is a question from truss, you can say, and for truss definitely. So if you proceed with method of joints, if you consider the equilibrium of point Q, okay, you will be able to solve it. So there are three different methods. Okay, I'll prefer the Lami's theorem because the answers will come out in as a matter of one line. Okay, the only thing that you have to analyze the direction of forces. You have to analyze the direction of forces, because if you have predicted the direction of forces correctly, only then you will be able to find out the angles, because angles between the forces is very important in Lami's theorem. Now, if you look at it properly, you should be able to understand, that if this is pulling down, member PQ will be elongated. वो खींच जाएगा, लंबा हो जाएगा. It will be elongated. So this will be under tension. Member PQ will be under tension. And QR, member QR, basically it is here. It will get compressed. It will get compressed. The member QR will get compressed. So it will be under compression, right? So if you try to find out direction of forces, so W weight is definitely there in this direction, right? Force in PQ, since it is tension, it will try to pull the joint Q. So this will be force PQ because it is trying to pull. It is itself, it is in tension means it will try to pull joint Q. And member QR is in compression. So compression means it will try to push the joint Q. FQR. So FQR, what I can do, I can actually shift it to the other side. I can actually shift it to the other side this way. FQR. So this is the three directions. So all the forces are radially outwards, right? None of the angle is greater than 180 degrees. So we can actually apply Lami's theorem. Right? So this is one way to analyze what will be the direction of forces. Now, even if you are unable to analyze it this way, आप बोलोगे sir, I am unable to see how it is in tension, how it is in compression, then also it is not at all problem. You'll not be able, if you want joint Q to be in equilibrium, if you want joint Q to be in equilibrium, this is joint Q, right? This is joint Q, this is joint Q, right? If you want joint Q to be in equilibrium, there is no alternative to this direction of forces. You try any PNC, you try any permutation combination, right? You'll not be able to find out anything else apart from these three directions. These forces, because the direction of W is fixed, you can try it, right? You have to do a little bit of analysis. This is what the direction of the forces. There are no other possible alternatives, options apart from these three directions. So if you do a little bit of practice, you will be able to know that, right? So now can I find the angles? So this angle will be, so if you see it here, this is 30 degree, the whole angle is 180 degrees, so 180 minus 30, that is equal to 150 degree. Similarly, this angle is 180 minus 60, that will come out to be 120 degree. This is 120 degree, and this is 90, right? So 150 plus 120 is 270, 270 plus 90 is 360 degrees, completely fine. So I'll apply Lami's theorem. So what does Lami's theorem say? F PQ by sine of angle opposite to PQ, that is 120 degree, is equal to FQR divided by sine of angle opposite to QR, that is equal to 90 degree, is equal to W divided by sine of angle opposite to 150. W is sine of 150 degree. So sine of 150 degree is equal to sine 180 minus 30, right? Though that is nothing else but sine of 30, half. So basically this term is 2W. So this term will become equal to 2W, right? So sine 90 is 1. So FQR is equal to 1. From this equation we will get FQR, sorry, not 1, 2W. FQR is 2W. And as I have said, it is compressive in nature. So the alternative way how to find out compressive is, suppose you have found out the directions. So you have found out the directions. Okay, first let us try to find out the numerical values first. उसके बाद हम देखेंगे FPQ, then we will see how to find out the directions. FPQ is equal to 2W sine of 120. Sine of 120 is sine of 90 plus 30. Sine of 90 plus 30 means cos of 30. Cos of 30 is root 3 by 2, right? So this becomes root 3 by the 2 into 2W, that is root 3 W. So I've at least found out the magnitude. Now I have to find out the direction, the Nature of forces. So how to find out the nature of forces? Now PQ is under tension. How to know? How to know? See, very simple. Once you have decided the direction of forces, once you have decided the direction of forces, okay, once you have decided the direction of forces, so you have decided the direction, you have finalized the direction of the forces, then you can easily predict by this shortcut trick that I'm giving you, if a member is pulling a joint, the member itself is under tension. For example, you see the member PQ is pulling joint Q, the member PQ is pulling joint Q, so member PQ is under tension. If a member is pushing a joint, you can see member FR, it is pushing joint P, because actual force I have shown it from this side, but in actual the force is in this side. Now this is FQR. So member QR is pushing the joint Q. If the member QR is pushing the joint Q, I can say the member itself is under compression. So QR is under compression and PQ is under tension. So what is the answer now? QR. So QR is the second one. So second one is 2W compressive. So answer is B. Answer is B. PQ is 3W tensile and QR is 2W compressive. Okay, let us move to the next question. Okay, question number 17. A block of mass M rests on an inclined plane and is attached by a string to the wall as shown in the figure. The coefficient of static friction between the plane and the block is 0.25. The string can withstand 0.25. The string can withstand a maximum force of 20 Newton. Okay. The maximum value of mass for which the string will not break and the block will be in static equilibrium is. Okay. The value of cos theta and sin theta is given. So this is a very simple question. Simply you have to draw the FBD of the block and you will get the answer. So let us try to find out the FBD. So I am drawing the FBD in the figure itself. Let me tell you, yes, for FBD we should not draw the surrounding, but for ease I am drawing the FBD on the figure itself, because this is an objective question and nobody is going to see how I have solved it. Okay. Had it been a subjective, I would have drawn the figure separately. Okay. So what are the different forces? Let me try to figure it out. So there is a mass. So weight mg. There will be a normal reaction n. There will be a tension force T. And definitely, what is the tendency of the block to in which direction to move in the downward direction, right? The tendency of the block is to move in the downward direction. So the frictional force will be F. Fs, static friction, will be in the upward direction. Now, since we have to find out the maximum value of M, so the case will be of limiting case. So if it is limiting case, so I can say Fs is equal to Fs max, maximum static friction, which value is equal to mu into M, right? So now I will resolve mg into two components along the plane and perpendicular to the plane. Let me resolve mg force into two components. So this is one component, this is mg sine theta component. If this is theta, this angle will be theta, right? So this is mg cos theta. So this is how the FBD of the block will look like. Now, if I write the equations, try to balance the forces, n is equal to mg cos of theta. Let me say this is equation number 1, right? What else? I can say tension T plus Fs max is equal to mg sine theta, right? So I'll substitute the value of Fs max. What is Fs max? Fs max is equal to mu into n. N is mg cos theta, so I'll directly write it T plus mu mg. I'll write it mu mg cos theta is equal to mg sine theta. Let me say this is equation number 2. So I have to solve basically equation number 2. So what is required to be find out? I have to find out the mass m. So I'll substitute the values. Let me substitute the values and see. Tension is 20, mu is 0.25, m is, I have to find out, 9.81. Okay, value of g is given as 10 meter per second square. Fantastic. So I'll simply write it as 10 is equal to m. I have to find out g is 10 sine of theta. Okay, I missed cos of theta. एक काम करते हैं, इसको ऐसे नहीं करते हैं. Let us take m common first. ठीक है. So I can write. Okay, I can write. If I take m common, let me take g also common. Let me take m and g common. So it will become sine theta minus mu cos theta is equal to tension T. This way it will be easier, it seems. M is equal to T divided by G into sine of theta minus mu cos of theta. So if I substitute the value, T is equal to 20 divided by 10, and sine theta is 0.6 minus 0.25 into 0.8. So if I substitute the values, it will become 2 divided by 0.6 minus 0.8 into 0.25, which is 0.2, which is coming out to be 5. So what is the value of mass? Mass m is equal to 5. So the maximum load, maximum mass that can be kept without the string breaking is 5. I hope this question is clear to you. Let us now move on to the next question. Okay. Question number 18. A small ball of mass 1 kg moving with a velocity of 12 meter per second undergoes a direct central impact with a stationary ball of mass 2 kg. The impact is perfectly elastic. The speed in meter per second of the 2 kg mass ball after impact will be. So this is again very simple question. Simply conservation of momentum. So this is a ball and there is another ball. Let me say this is the 1 kg ball, mass m1, this mass m2, and its mass is 2 kg. So initially this ball was moving with a velocity v2 is equal to 0, and the mass m2 was stationary, and mass m1 was moving with a velocity of 12 meter per second. 12 meter per second. Right? So after collision, what has happened after collision? So this is before collision. After collision, let me say the mass m1 has a velocity of v1 dash and mass m2 has a velocity of v2 dash. Initial velocity of mass m1 is 12 meters per second. So this is the case. The upper part is the before collision, then lower part is the after collision, right? So let me say this is the scenario. So I am going to apply conservation of momentum. Conservation of momentum. So if I apply conservation of momentum, so what I am going to get is m1 v1 plus m2 v2, that is momentum, total net momentum before collision is equal to net momentum m1 v1 dash after collision m2 v2 dash, right? So now if I neglect this one, this is equal to 0 because initially the velocity of the 2 kg mass was 0. So what I can say, this implies m1 v1, let me substitute the mass 1. What is v1? v1 is 12. Okay, this is equal to m1 is again 1, v1 dash is not given, m2 is 2, v2 dash is not given. Let me say this is equation number 1. Okay, now I will have one more equation. What is that? For perfectly elastic collision, for perfectly elastic collision. So what I can say, the coefficient of restitution E is equal to 1, and what is the value of E? E is equal to velocity of approach, sorry, velocity of separation by velocity of approach, velocity of separation divided by velocity of approach. So what is velocity of separation? The after collision, the difference in velocities. So I can say v2 dash minus v1 dash. What is velocity of approach? The rate of change of distance before collision, that is v1 minus v2. v1 minus v2. So from this equation I can say, so v2 is already, you know, it is 0. V2 is, you know that it is equal to 0. And I can rewrite the equation like this. This implies V1 is 12. So V2 dash minus V1 dash is equal to, so this is equation number 2. So you can see there are two equations. V1 dash plus 2 V2 dash is equal to 12, and V2 dash minus V1 dash is also 12, right? So what I'm going to do is I'll simply add equation 1 and 2. If I add equation 1 and 2, okay, if I add equation 1 and 2, what I'm going to get is, I'll add these, 12 plus 12 is 24 is equal to 3 V2 dash, right? This implies V2 dash is equal to 24 by 3, that is 8 meter per second. So you are asked the velocity V2, I hope so. Speed of 2 kg mass, that is V2. This is the answer. I hope it is clear. Let us move on to the next question. Okay, question number 19. A swimmer can swim 10 km in 2 hours when swimming along the flow of the river. While swimming against the flow, she takes 5 hours for the same distance. Her speed in still water is. Okay, so this is a question from kinematics. Very simple question. This type of question we used to do when we were in class 10. So let me assume that the speed of the swimmer in still water be x. Let speed of the swimmer, speed in still water, is equal to x. If speed in still water is x, so what will be the speed along the flow? Speed along the flow will be x plus, and let me say speed of speed of river is equal to y. So what will be the speed of the swimmer along the flow? Speed of swimmer along the flow is equal to x plus y. Both of them will get added up because swimmer is swimming down, right? And the flow of water is also in that direction. And speed of swimmer opposite means against, or let me say against because in equation it is given against the flow, that is equal to, against the flow will be speed of the swimmer minus speed of the river. Okay, so what is there given in equation, right? So it takes 10 hours when swimming. The swimmer can swim 10 kilometers, sorry, in 2 hours when swimming down. So I can write 10 divided by x plus y along the flow is equal to 2. This is equation number 1. And while swimming against the flow, she takes 5 hours. The same distance, 5, equation 2. So if I solve these two equations, so the first equation will be 10x plus 10y is equal to, sorry, 2x plus 2x, equation number 1 will become 2x plus 2y is equal to 10. Equation 2 will 5x minus 5y is again equal to 10. So what I will do is, I'll multiply equation 1 with 5 and equation 2 with 2. So what I'm going to get is 1 into 5 implies 5x, sorry, 5 to the 10x, 10x plus 10y is equal to 50, and equation 2 into 2 I'll do, so I'll get 10x minus 10y is equal to 20. Let me say this is equation 3, this is equation 4. So what am I required to find out? I am required to find out her speed in still water, means I need to find out x. I'll simply add equation 3 and 4. I'll get 20x is equal to 70. So what is the value of x? The value of x will be 3.5 meter per second. So if I add these two equation 3 plus equation 4 implies 20x is equal to 70, x is equal to 3.5 meter per second. So this is the required answer. So this was a pretty easy question. I hope it is clear to all of you. Let us move on to the next question. Okay. Question number 20. Two identical trusses support a load of 100 Newton as shown in the figure. The length of each truss is 1 meter. Cross-sectional area is 200 mm square. Young's modulus E is equal to 200 gigapascal. The force in the truss AB in Newton is. तो इसमें इतना जरूरत नहीं था so much of data why to give Young's modulus and all these things. All these data, extra data provided to make you confused. So I'll draw the FBD of point P. Okay. Consider joint B. So if I consider joint B, there are three forces acting on it. 100 Newton. Let me say this is force F. And by symmetry, I can say both the forces will be same. You can see if you draw a line, passing through point B, vertical line, you can see the right hand side and left hand side are exactly same. So I can say this is a symmetrical structure. So definitely the force in both the members will be F. Same, I mean to say. Okay. I also know the angles. Angles भी मेरे को पता है. This is 30. This is 30. Right. So I can resolve the forces. In this direction. So this will become 2F, because both the forces component will be there. 2F sine 30. This will be F cos 30. This will be F cos 30. The horizontal force in the horizontal direction will get cancelled out. Right? So vertical force will get balanced. So I can say summation of force in y direction should be equal to 0. This implies 2F sine 30 is equal to 100. From here, if you calculate the value of F is equal to 50 by sine 30, and sine 30 is half. So F is equal to 100 Newton. The answer is required to be in Newton. So this is. Okay, I hope it is clear to all of you, all the questions. So we have solved question number 11 to question number 20. Next video will be from question number 21 to question number. Okay, bye bye. I wish you best of.